Right, so let's start to code this up. I am going to click the plus code button here, and the first thing I'm going to do is write a comment, just letting everyone know that I am going to import required modules. And to begin with, I'm going to import two things. I know I'm going to use the random module, and specifically, I know which methods I'm going to use from it. So I'm going to say from random import sample, comma choice. So they're the two methods I'm going to use from random. I'm also going to import matplotlib.pyplot as plt. So slightly different. I've imported that in a slightly different way. If I just do import, it'll import everything from matplotlib.pyplot, and I've relabeled it plt. So anytime I want to use a function from this module, I can just do plt dot. Okay. Right. I'm going to start a new cell. Shift and enter to do that. And I'm going to define my environment class. Okay, now we're going to be using class objects throughout this. It's really important that you get used to doing this. Very, very difficult to explain what a class object is. The best way to go and learn about that is to go and do the course that I said to do on LinkedIn. And that, if you do all of that, the very last chapter in that gives you an introduction to object-based coding. But I'm going to create a class like this. Class, I type the word class. I'm going to give it the class and name environment, open bracket, close bracket, colon, and I've used a capital E. And the first thing I'm going to do here is I'm going to have a function, def, I call it an instantiation, this init, and I'm going to pass it itself. And I'm going to have a default for the size of my environment of 1,000. And I'm going to have a density of food, density of 0.1 or 10%. So these are the default values it's going to have for those, and I'm just going to instantiate those values. This instantiate is a posh word for setup, right? So I'm going to create a variable called self.size equals size. So that's just a single number telling me how big it is. I also want a variable called self.x, and what I want this x to be is a list of numbers between 0 and 999. Okay, and to do that, I use a range function from 0 to size. Okay, that'll be very, very useful for me later. I'm gonna define self.food density. I'll give a brief explanation of why I'm using the self dot in a second. And I'm also going to create another list which contains all of the positions of food in the environment. Okay, and I'm going to distribute that food randomly. So I'm going to create a variable called self.food_pos equals. Now I'm going to use that sample function I've imported above. I'm going to sample my self.x list, and I basically want to take, in this case, 10% of random items in that list to determine where my food's going to be. So to do that, I'm going to do size times food density. Okay, so I'll do 1,000 times 0.1, which causes 100. So there'll be 100 pieces of food in the environment. I'm also going to make sure that that's an integer, just in case I do something silly like 0.0001 or something like that. So the very minimum limit to the food coverage, or the pieces of food, is going to be 1%. So in this case, I can have a minimum of 10 pieces of food in the environment. Okay. And then I'm going to shift and enter that. So I've created my environment class. Just to give you an explanation of why I've used this self dot notation here. Anytime you see the word self, it's basically a way for you to get a handle on the class. So if I create an environment, so I'm going to create an object. So nothing's happened yet. I haven't created anything. Let's create an object called new environment or new env. To do that, I will do new env equals environment. Okay, and that it's created that object. If I do new env and just press enter or shift and enter, it'll just spit out the object identifier, which isn't much use. But if I do new env dot size, it will of course give me the 1000 that I put in, or 1000 it took by default. I could incidentally specify an alternative size. There you go. So by default it takes 1000, but I can put in any other number. Let me get rid of that, keep the defaults for now. I could of course get the X, which as you'll see is just that range generator again. And if I do food pos, it will give me a list of 100 random integers in the range 0 to 999. Okay. If I want to fully inspect the object, I can do __ dict __, and it will throw out everything. So it's got that massive list again, but at the top here it will have size, X, food density, and food pos. Okay, let's get rid of that. So let's just visualize what's happened here. Let's plot a quick graph. This way, this is how I'm going to do all of my graphs for this project. PLT subplots. So I've basically taken the subplots method from matplotlib, and it's generating a figure and an axis variable. And then I'm going to do ax.plot a new env food pos. So I'm plotting the food in the environment on the X. I'm actually going to do it on the Y as well, even though I'm only in one dimension. And I'll get a diagonal line, essentially. The other important thing to do is, if by default that ax.plot function is going to join all my dots, I don't want to do that. So I'm going to put a little 0, a little O in quotation marks at the end of that to plot it out. And there you go. So I've got 10% coverage on my environment. If I want to create an environment, actually, yeah, that's 10%. If I want 1%, I'll run all those again. And there you go. I've only got 10 pieces of food in there. Anytime I update the environment class, I have to run the cell again, and I also have to create a new object in order to do anything with it. Okay, so that's the environment class to begin with. We're going to be updating that a lot. But I think next we will actually create another class for our organisms. Okay,